In this example, I want to show you that we can use phasor transforms to do steady-state analysis on circuits that contain operational amplifiers in the same way we've done it for DC circuits. So in this circuit, we're given that the voltage source is actually driven by a sinusoidal, or is a sinusoidal source that has a 50,000 radian per second radian frequency or angular frequency and a magnitude of 25, and we're being asked to compute V naught. And of course, there's actually this 250 picofarads in here. Okay, so where do we get started? Well, it's in the same exact way that we've done with DC analysis. So we have the same assumptions. Basically, the first assumption is the current in here, which I'll call IN, is 0, and the current in here, IP, is 0. And also we can say that V of P and V of N are exactly 0. But before we do all of these, we're going to have to move to the phasor domain before we actually do this. So how do I move to the phasor domain? Well, I'll reiterate, or I'll do the following. So let's convert that V of G. So that V of G here is simply 25, and the angle in here is 0. At omega is 50,000 radian per second. Okay, and what about the 80K? The 80K here, the 80K, the 20K, they're all the same. The 40K is the same. Now, of course, now what we have in here, instead of lowercase v naught, we have an uppercase v naught. And the thing that changes actually this capacitor in here, it does change. And the reason why it changes is because if you remember, capacitors exhibit an impedance of 1 over j omega c. And if we compute this value for this particular capacitor, what we'll end up with is negative 80 j kilo ohms, because it's negative 80,000 j of ohms. So basically I just took the 1,000 and put it k. And you can compute this. Of course, as a quick reminder, picofarads is equal to 10 to the negative 12 farads. Okay, picofarads is equal to the 10 to the negative 12. This is very small. Anyway, so you compute this, and this is what we have. Okay, so now what do we know? Of course, now we have V of P and V of N and I of N and I of P, but now what we're going to do is we're going to write them in uppercase letters, because now we are in phasor domain. Okay, so this is V of P, this is V of N. All right, can we actually figure out what V of P is? We can just apply voltage division, because the 80 and the 20 are in series. So what we have to do, well, in series because the I of P is actually just 0 in here. So what we can do is we can say that V of P is simply VG, which is 25 times 20 divided by 20 plus 80, basically 20%, okay, of the 25. Which happened to be 5, and the angle is 0, and that's in volts. And of course, V of N is the same as VP. And it is 5 volts as well. All right, so now we know what V of N is, okay? So do we need to write nodal here? Well, actually, let's think about it. Do we have any other points to write nodal? We shouldn't be writing nodal in here because I don't know the current leaving the operational amplifier. So that leaves me at this point in here, which is the same as V of N. Yes, I know it, but it will be helpful because it will include V naught in here. So I write nodal equation for the V of N. So, and I'll highlight it. This is the same node in here, okay? So I'll write nodal equation there. So nodal tells me the following. It tells me V of N minus 0 divided by 80K plus V of N minus V naught divided by the negative 80JK. Okay. I don't need to write K. We're just going to write it as negative 80J. Plus I will have V of N minus V naught divided by 40 kilo ohm equals 0. So what I've done is, this one here is actually corresponding to the current flowing through the capacitor. It's a V of N, which is here, minus V naught divided by the negative 80J, because I'm dealing with impedances as resistance, and the same goes for the 40 kilo ohms. We have V of N in here, V naught in here. All right, so do we know actually what V naught or Vn is? We do, so all we have to do is just substitute it. So 5 divided by 80 plus 5 minus V naught divided by negative 80J plus 5 minus V naught divided by 40, and that equals 0. And we'll be able to figure out what V naught is in the phasor domain, and that will be, based on my notes, is 7.07 and negative 8.13 degrees, and that's in volts. Of course, this is not the final answer, because what we're looking for is V naught in the time domain. Okay, so we need to do an inverse phasor to get what V naught is. And just remember that here, actually I'm going to drag it here so that we don't have to remember it, because everything is based on this omega. So V naught of t is simply 7.07, and we converted the cosine here. So this one here is also cosine, okay? And omega is 50,000 t minus 8.13 degrees volts. So this is how the output is related to the input. So if you think about it, what happens with this operational amplifier is a couple of things happened. The amplitude of the input got reduced, okay, and at the same time we had some phase shift of 8.13 degrees. So now the output is lagging behind the input by 8.13 degrees.